Hey folks, Mark Locklear here in this screencast on Chapter 6, how to work with data types, strings, and vectors. So pretty dense chapter, a lot of good stuff in it though. I would just encourage you to play with the code in each section. This is a lot of string manipulation. I mean, a lot of it as a programmer is just going to be very, it's very nuts and bolts kind of stuff. Like often in programming, we're having to ingest some text and we're having to search for things, search for strings. And we'll look at the example that you do in the homework where we're going to be adding the email validation. Very common kinds of things that you'll do where you're looking for, looking for a particular password complexity, looking for a particular domain name, something like that. So we'll look at that in one of the homework examples. Also with parsing strings, you're having to loop through strings to either print out characters. Same thing with vectors, using loops to loop through vectors. We'll also look at that as one of the examples. So I think what I'm going to do is just do a quick, we're going to look at vectors real quick. I just want to make sure you're okay with that concept, and then we'll be building on that as we go further in the class, and then we'll look at one of the homework examples. Okay, so I'm going to share my screen here. So we'll share the desktop. Alrighty, so let's look at vectors first. Just a real super simple example. I just sort of want to walk you through the structure of a vector. So if you've dealt with arrays in the past, I mean, a vector is a kind of array in C++. It's in fact, this sort of out of the book. It's a vector is a sequence of elements of the same data type. So often in programming, we've got these sets of data and we want to store them in an efficient way. So that's all an array or a vector allows us to do. Vectors are dynamic in C++, so they can grow in size, although you can set an initial size, but they'll grow. And it just really depends on, number one, the size of the data set that you're talking about. An array with a sort of preset size is going to be way more efficient than a vector that is dynamic and can grow in size. And I think the book goes into a little more detail about that. I won't cover it here, but so certainly you can read more about it there. So in this real simple example, I'm going to create just know too, when you're creating a new program and you're experimenting with these, I had to be sure to include the vector library here, and then also I added this using namespace standard, so I don't have to put the std in front of everything. But here I'm creating a vector of strings. That's what the strings tells us. This is a vector of strings. I'm going to name this vector colors. I could name it anything I want, but generally you want the name of any kind of element or object in programming. You want the name to reflect what it is. So in this case, we're calling it colors, and then the colors I've got here: blue, red, and green. Now, when I want to access these, notice I'm using the element number to identify. In this case, 2 is going to be green. Again, don't get confused by what we often call off by 1 errors. That, remember, in computer science or in programming, we always start counting with 0. So in this case, 0, 1, 2. Blue would be 0. Red would be 1, and then of course green is 2. And you can see the output here. I've already ran this previously off screen, so that's why it prints green. Obviously, if I do 0 here and I run this, we're going to see blue in the output. So again, that's all that element designation does. And then if we want to loop through, oftentimes we'll be retrieving data, and then we want to list or display all of our retrieved data. Loops are generally how that's done. In this case, we're using a for loop, and we're just going to loop through, and then inside we've got a print statement inside here that's going to output the color. And all we're doing is iterating through the variable I here. We're starting I off at 0. We're going to add each one. We're going to add 1 each time we go through the loop, and we're going to run this as long as I is less than colors dot size. So that's a way that you never have to worry about an out of bounds error if you do this, you know, using the size, calling the size method on the array or vector. You know, always, most of the time at least, make sure you're not going to run into an out of bounds error. And of course, you can see when I ran this, I got all of the elements there. The other thing that's nice about using that size is I could go in, and if I dynamically go in and add purple here, let's say my daughter's favorite color, you know, notice I haven't had to change anything or do anything, and it's automatically going to count. It's automatically going to account for the fact that I've added another element to it. So whether I add one or I add a million elements to it, it's going to loop through all those elements that I've created there. Okay, so just, you know, make sure you're comfortable with vectors and arrays and the syntax. We're going to be looking at arrays and linked lists and some other things later on in the semester. Generally, the rules are the same for these. Students often ask, when should I use one over the other? And it really depends. You're probably not at the level now, and even the amount of C++ programming I've done at a high level, it's hard for me to give you a distinct time and okay, you would use one over the other. It really just depends on the scenario you've got. This is really sort of a survey course for C++. We're showing you a very broad array, no pun intended, of things that you can do in C++. And the idea is once you get out in the real world and you're doing real work, you'll have more context for when you should use maybe one style of programming or one data type or method over another once you gain experience. So it really just depends on things like the size of data, how efficient you want it to be, and things like that. Okay. All righty, let's look at our homework. One of the homework exercises, I think what I'll do is get you started. In fact, I'm going to do it for you. So don't watch this if you want to take a stab at. This is going to be exercise 1. So I'm asking you to, let's see, yeah, it's exercise 1. I'm asking you to complete exercise 6.2 in the book. In addition to the book requirement, let's imagine that our company has decided it only wants to allow AB Tech students to sign up for an account. So you're going to refactor the program so only users with an email that ends at abtech.edu can register. And then I've got a hint there that you can use the find or rfind feature. So basically, I'm going to show you how to do it. I mean, it's only about 4 lines of code. So if you want to take a stab at trying to solve that before you finish this screencast, you know, hit pause and spend some time looking at the find statement first. But essentially, so what we'll do here is you've really already got a format for how you want to solve this problem, right? There's already a bunch of text parsing and sort of what I call data validation going on already. So rather than reinvent the wheel or do something totally different, you know, than what the program's already doing, you can very much look in the examples they've got here. So in this case, notice they've got a bunch of these valid email statements, and essentially they're doing checks. You know, for instance, here the comment says make sure at least one character, make sure there's at least one character before the dot character. You've got an if statement. You're doing a cout statement that's going to give that's going to be the failure statement. So if the you know, if the user doesn't fulfill the requirement, what error are you going to display? And then you're always setting this valid email flag to false. The idea is this will keep running until the user gets it right, and then when the valid email flag is true, then you'll fall out past that. So really all we're trying to do here is, you know, I would come down here, we're going to add a new if statement. So I'm just going to sort of put some comments in place, and I'm going to say make sure email contains abtech.edu. Okay, so we're going to do an if statement that's going to check for the existence of abtech.edu in the email string. If that fails, then we're going to do some cout statement that's going to give an appropriate message back, and then we're going to set the valid flag. So again, if you know, these comments, as you're sort of logically thinking about solving these problems, you know, this is a good way to do it. So for instance, I'm going to come in here and say, if statement to check for abtech.edu. So I'm going to do that. Then next I'll do a cout statement. I'll just say cout statement with error message. And then finally, I'm going to set valid email flag to false. Okay. So let's sort of walk through these. So your if statement, we know we're going to have an if statement, and that we're going to do something inside here. And then if that is true, or we could do like a not statement, it could be false. Then I'm going to come down here and close my curly braces. Our cout statement is going to say something like, and of course I've already sort of got this figured out off camera. Our cout statement is going to say something like this, which is, you must use a valid abtech email address, and then of course valid is going to be false. So I'm going to do valid email equals false. All right. So what I'm looking for here is some kind of statement that is going to be, it's a little bit backwards, but I'm looking for some statement that if it's true, which is going to be the failure state, which means abtech.edu is not in the email address, then we're going to run this code, okay? And I'll just go ahead and paste it in. I chose to use the find. Again, there's a bunch of different ways you could do this, but let's see. Let's just stick this right in here like that. So I did a simple, got too many ifs. I did a simple find statement, and all I'm saying is, again, so remember the email variable we defined farther up here, and we're getting, yeah, I think we're getting the email address when they enter it here. And so once they do that, we're simply going to do a find statement on the entire email string. And now in this case, notice what we're doing, if abtech.edu is equal to -1. So now why is that? So if you go back and look at the documentation in the book, this is not clear as mud in the book because they don't really talk about the failure statement, but they do mention, so the find method can take one argument or take two. In this case, we're using it where it only takes one argument. So if it finds an instance of this, it's going to be more than one. So the return state of this method is if it finds the particular string you're looking for, it'll give you the element or the character space, I think is what it is, of where it finds that string at. So in this case, what we're saying is, hey, if you don't find, if abtech.edu, if email.find abtech.edu equals -1, which means I didn't find it, then I want you to run this code, which is you're going to display the error message. You're going to set the valid email string to false, okay? And let's sanity check this and make sure it works the way we want it to. So I'm going to enter my name. I'm going to enter a password. And I think it's got to have a number and a special character. So let's test the failure code path first, right? So I'm going to say mark at google.com. Okay. So notice we've tested the failure state here. You must use a valid abtech email address. All right. So now let's test it and see if it'll pass mark at abtech.edu. Okay, so we got the successful, if you will, code path that time. We got thanks for creating an account. So that's sort of what the process is. Again, the find and rfind, and then there's a few other, I think, string or text parsers or string parsers you could use there. So it's really just a matter of, generally when I approach a new method like this, first thing I'll do is create the simplest program I can that's going to use, very similar to what I did with the vector program that we just looked at. Create the simplest program you can where you're going to input some text, and in the case of the find, you want to look at what the return values are and then sort of structure your code based on that. Okay, that is all I have for now. Good luck, and as always, let me know if you have questions.